This is the first session which we are going to start after keynotes. Actually, keynote speakers are giving their presentations. They started a little late. I want to warmly welcome you all to our third IEEE conference, international conference, which is hosting by MIT University in Tashkent. I'm Dr. Alisher Jalilov, moderator of this session. We have two session chairs. First, let me introduce our session chairs. So we have a session chair, Professor Dr. Noor Izri bin Abdul Wahab from University Putra, Malaysia. He graduated from the University of Manchester Institute of Science and Technology in UK in Electrical and Electronic Engineering in 1998 and received his Master of Science in Electrical Power Engineering from the University Putra, Malaysia in 2002. And he received his PhD in Electrical, Electronic, and System Engineering from University Kebangsaan, Malaysia in 2010. He is an associate professor at the Department of Electrical and Electronic Engineering, Faculty of Engineering in the University Putra, Malaysia. He is the member of the Advanced Lighting, Power, and Energy Research in University Putra, Malaysia. And he's a registered chartered engineer under the Engineering Council of UK and the Institution of Engineering and Technology in UK, and the professional engineer awarded by the Board of Engineers in Malaysia, and a member of the Institution of Engineers Malaysia, a senior member of IEEE, and a member of the IEEE Power and Energy Society, a member of the IEEE Computational Intelligence Society, member of the Institution of Engineering and Technology in the UK. And his areas of interest include power system stability studies, which is dynamic and control, and application of artificial intelligence in power systems and power quality. We have one more session chair, Dr. Manjit Singh, and he's currently serving as assistant professor at the Government College Bahanswal Kalan Sonipat, which is administered by the government of Haryana. He's proud alumni of National Institute of Technology, Kurukshetra. He is having more than 10 years of teaching and industry experience. He has published more than 25 research papers in various international journals and conferences. Over the course of his career, he has been conference chair and editor for more than 10 IEEE international conferences. I warmly ask you, Professor Dr. Noor Izri bin Abdul Wahab, be the session chair of this session, please. And Dr. Manjit Singh also. Sir, before you start, I want to mention that so we are given 5 to 8 minutes for each presentation. So just say the elements. Thank you, sir.
So we have Assalamualaikum and good evening to everybody. Thank you for joining this session. So thank you for Dr. Alisher for give introduction to me. So and I think we have around 10 papers, 10 presenters.
Yes, sir.
Yes.
Yes, sir.
Yeah. Okay. So I think the paper ID is extract number 4, right? 20, 404, 465, and so on.
Yes, sir. Yes, sir. We have ID 20, the first one.
So yeah, 20, the first one. So all the presenters ready?
I think so. So
yes, sir.
Yeah. So we can call. I think we can call with the first presenter from paper number 20, because I don't have the details on the paper. So maybe Dr. Alisher can help me on this.
Yes, the first presenter by the paper number 4, the future of GEOS mitigation and exploration of machine learning algorithms.
Okay, so the timing was how was it? The timing 5 minutes?
5 to 8 minutes. It's up to presenter, of course. We have also QA. So I think it's better to give 5 minutes for presentation and 3 minutes for QA. question and answer, I guess.
Okay. So please, the first.
Yeah, presenter can share the screen. I think the presenter is Ravlin Kaur Chatra ma'am, right?
Yes, sir. My
Yes,
teammate
ma'am.
has just presented the PPT just now.
Understood. Yes.
So, good afternoon to everybody present here. The title of our research paper is The Future of DDoS Mitigation and Exploration of Machine Learning Algorithms. So we'll quickly dive into the abstract and then so we've I'll start by explaining what is a DDoS attack basically. So a DDoS attack, meaning distributed denial of service attack, is basically an attack where in a website a lot of bots or even people, even humans could do that. They flood various IP addresses into the website or whatever server um, the person is using, and they flood it and make it impossible for the server or the machine or the website to work. This may lead to financial losses and various other losses which could and this is basically the summary of a DDoS attack. Then moving on, I would like Gautam Sharma to give a little idea about the methodology of the path that we've taken for the uh, mitigation of the DDoS attacks.
Good afternoon to all. I will give you brief introduction about the methodology we are using in our project. First of all, we will collect all the data set from the file which we are using from the Kaggle. Then, after collecting the data set, it then after collecting the data set, we will use the feature extraction to extract the features from the data set which we are using manually in the code. Then we will drop irrelevant columns so that our model can work faster than the other models. Then we are processing the data in our code. After processing it, it will train the models. It will give us choice. We are using four different algorithms: random forest, decision tree, Gaussian, and NB, and ML. Then it will ask the user to give the input that whether which model he or she wants to train. Then after getting the input, it will train our model. And after training the model, it will evaluate all the accuracy, precision, F1 score, and other data related to the model, and it will show us a pie chart form of the result. And after that, we can save the model in the local storage also using in library of Python pickle, and we are using pickle dump to store the model training data in the local storage. And after that, we can use the trained file data to use in the testing purpose. Then it will generate two output labels, benzene and DDoS, which will give us the result whether the DDoS attack is done or not. Now my teammate Pushkar will give you brief introduction about the results and the discussions. Thank you.
Good afternoon, sir. So as Gautam stated about the train.py file, so we are using that file to train the different models we have, and using these data sets, we are designing a comparison confusion matrix, which will compare among these machine learning models. So firstly, we have the accuracy model. So accuracy is used to Accuracy is one of the metrics of a confusion matrix, which is used to measure the performance of a machine learning model. It is generally defined as a ratio of total number of correct instances to the total number of instances produced by a model. As we can see here, Gaussian naive Bayes has the least accuracy among the four. Now moving on to precision scores. So precision is used to measure how accurate a model's positive prediction can be. So it is generally ratio of total number of true predictions to the total number of correct prediction produced by a model. Now moving on next to the recall scores. So the recall score is used to measure the effectiveness of a machine learning model. It is this ratio of the total number of true predictions upon the sum to the sum of the total number of to the sum of the true positive and the false negative. Now, last one is F1 score. F1 score is used to find the overall performance of a machine learning model. This is the harmonic mean of the recall scores and the precision scores. So as we can see, among all the graph, we can see that the random forest is the best machine learning model we can use here. Now coming on to the future enhancements, we can do many future enhancements in this topic. So first one is like we can use more real-time data set, which is generally used by the attackers during the DDoS attack, that will help to train the model in a better way. Secondly, we can add more machine learning algorithms. Thirdly, we can combine various algorithms which will help us to provide the improved result as compared to the past ones. Lastly, we can use automated machine learning techniques which would for the feature extractions. Like currently we are doing it manually, but if we will use automated machine learning, that would provide us a wide range of feature combination and algorithms. So here are some references we have used, and thank you, sir, for giving us this important time.
Okay, thank you very much for the team to present the paper. Any question from all the listener or participant? Do you have any questions? Okay, if no, then maybe I can give some question. I just wondering how many data are you using for the problem? Okay, and then I see there are many techniques and they are not the similar, because MLP is different than decision tree and all this naive Bayes, all this. So how do we see? I just want to know how the data is. How many data is used for the training? Can anybody answer from the team?
Sir, I think Gautam wants to answer, but he's mute currently. He's
Okay,
speaking on mute.
Sir, for training, we are using a already generated data set that is present on the Kaggle website. We download the DDoS file directly from the Kaggle, then we just use the hard file path from the local storage. Then it will train the data and predict the tables according to the code, whatever we are using to use in a pandas for data frames and dropping columns and all of that.
Yeah, and just last question. Because you say the enhancement just now, you will do further different techniques and maybe hybrid all this, but I see from the results is already 100% the accuracy, and some all other state the results is all nearly perfect in some of the techniques. So how do you improve it's already 100%?
So it's not
So
100%. It's like near to 100%. It's 99.9. But we would do
I would
more
just
data.
like to correct you. I would just like to correct Pushkar over there. Yes, we do have 100% results from random
Yeah.
forest, and I would say that the thing is that took a lot of time. So with feature extraction and all of those things, I think we can still save on a lot of time on finding on the results. That is one major point that we feel that could have been improved. If that was in our hands, we would have surely improved the timing of the results. Yeah.
The time for training or the time for the data, right?
The
time for training the
training,
model, sir.
sir.
Data for training. But
Yeah.
so you mean you want to reduce the number of data?
Yes, sir.
No, sir. We
No,
want to
like
increase the number of
reduce the time.
data, reduce the time. We want to use a larger set of data, but the time should be lesser.
Okay. Thank you very much.
Thank
Thank
you,
you
sir.
Thank you,
Thank
sir.
you.
for the presentation. Okay, so now we call for the second paper. Dr. Alicia,
Yes, yes, sir. We have a second paper by Miss Rupa Rani, which is called like driver snoozing system with infrared technology. Do we have?
Yes, sir.
this-
Yes, sir. I'm presenting, sir.
Okay, so you may share your presentation, sir.
Yes, sir. Just present. Is that visible, sir?
Yes.
yeah, you see, yeah. Just the title page, yeah. Maybe it's up on the title page. Yeah.
Is it clear visible?
Yeah, yes. Your paper
Okay.
number? You remember?
Sir, 121. 121.
121. Oh, okay.
Yes, sir. So, good afternoon, everyone. My name is Dipansh Best, and I'm the one of the co-author of this manuscript. Our manuscript title is Driver Snoozing System Using Infrared Technology. So we have less time, so I'm moving to directly to the abstract. So, moving to the abstract, our proposed model for the driver snoozing system leverages the combined capability of normal camera and cutting-edge infrared technology to significantly enhance the detection accuracy and address the issue of driver fatigue leading to the road accidents. Basically, the existing models are mostly revolves around the facial expressions and EEG data, but here what we are doing, the our basic concern is we are using two cameras. One is the normal camera for the facial features, and second was an infrared camera that detect the minor oscillation of skin temperature. So our strategy incorporates, just I told that we were using twin camera. One will be in, both will be placed over the dashboard of the car vehicle, whatever our driver is driving. So moving to our introduction, this is the start we have from NHTSA, that is National Highway Traffic Safety. According to them, in 2017, they have reported 320,000 crashes, in which 6,400 fatalities were there. And going to the 2021 research, NHTSA reported that 96,000 police reported the crashes, where the 52,000 were the injuries and 800 were the deaths, and most were found like the driver was not properly awake, and he was feeling nodding. So before going further, I must tell you what exactly a drowsing or snoozing is. So snoozing is basically when a driver or person is not getting the difficulty keeping eye open and frequent head nodding, uncontrolled yawning, and these were the characteristics. So what we can define as snoozing or drowsing. So this is the introduction part. Moving to next. This is the existing systems which are these are the existing systems the work has done. Upper three is our DDG. First one is facial features. We have already covered this by our normal cam. Second one is EEG. EEG is graphic self-graphy. It's you. This study is basically you have a device that revolves around your scalp and detect the brain signals through which it detects whether the driver is feeling any kind of sleep or not. And the accuracy, I have mentioned that above 3 hours are getting 80%, 90%, 85%. But here our proposed model use the SVM, and you all are the researchers in machine learning and NLP. You know that SVMs are very good in classification and regulation in terms of classification and regulation, and they achieve through our model in a small scale. We have right now we have done in a small scale, but whatever we have done, we are getting the accuracy of 90 to 98% because the our normal camera is taking facial expressions. So this is one of the this is one data set when the classification is done, and another camera which is our infrared camera that is providing our minor oscillation, skin temperature data. So combining both data eventually increase the accuracy of the model. So going to further, these are some companies which I have done some work over this, but they, as I mentioned, that in the field right now, no model has already accomplished the integration of a normal camera and an infrared camera. But here I mentioned what they have done. They were same the vehicle dynamics. Vehicle dynamics are the properties like motion of the vehicle, how far the vehicle is moving, activity of the driver. So, but they have not mentioned that they are using any kind of infrared technology. Uh, so this is a literature survey. Literature survey. Just these are the base papers. First paper states that the possible this first paper tells about the how frequently the cases of increases cases of driver which is falling drowsiness occurring. Second one is the mass production of the technology that detects because people think that this technology can lead to the reduction of the accidents that occur daily, yearly in every phase. So moving to this proposed architecture. So how I have given a flow chart and a picture, and you can see there's a normal camera which I told that going to tell the collect the facial collect the facial properties or facial data. And infrared is for the minor to detect the minor oscillation around the skin. And from flowchart we can there will be initialization of capturing of images. First was this one is the normal camera which is taking the facial images, and infrared is taking the minor oscillations of skin temperatures. So combining both data, the system will check whether the property we have the data set. One data set is around 2.6 GB, which is for facial, and another one is for infrared. It was around because of less research over this topic, the data is around 600 to 500 MB. So, but we have the infrared data too. So by matching both data, we get the comparing using, as we know, we are using I mentioned earlier, we are using SVM. So SVM will classify from the previous data whether the whatever the output we are getting is matching to it, and it will tell the system that yes, the driver is leaning kind of a fatigue and they have to stop, they have to alert him. So this is some of the formulas we have used. We have for to get the correctness of our accuracy. We have the true positives, how many times the data has provided correct predictions, and false negative, how many times they are not provided the correctness. So next is the equilibrium distance. This is an interesting part. So equilibrium distance is kind of like we use in SVMs in a experience from a cluster. We have 2 points and we calculate their distance, and we make them fall that yes, this thing belongs to this clusters, and this point belongs to this cluster. Same in our model, we are using fluent distance, but here the points are the facial expressions, like points are a1 and a1 to a2 are the points between our eyelet. So like upper eyelet is a1, upper eyelet is a2, and B1, B2 is from left eye. And to calculate the eye aspect ratio is the distance between center of the each eye and the bottom of the each node. P1, P2, these are the center of the, like P1 is the center of the eye, P2 is the right corner, outer corner of the eye, and P2 inner corner of the eye. So moving to results, what you have acquire. So we acquired a system that can detect the drowsiness of any driver using IR and normal cam. So these are some pictures we have. This is an infrared images that detecting a user. This is one of our co-fellow, and this is me. This is the normal camera functionality that detecting the facial expressions. One is for the infrared, and these two are the for normal camera activities. So future enhancement, like as we are told, this is on a small scale. So so definitely, if we are incorporate with model developed algorithms, accuracy will be more more increase, and for the sake of life, 95 to 98 it's not a quite, it's a quite a good accuracy, but we can achieve it to 99 to 100% because life is very valuable and it requires a lot of time to train the data. So right now, so it will get soon developed, and we can use the modern algorithm to save the energy too, because like we have enough daylight, so we can use normal camera in that condition. But during nights, the facial expressions is not able to detect by normal cam because of dim light. So there we can use the infrared. So switching between these cameras can reduce in the energy consumption too. So another point I mentioned, that monitor addition physiological parameters. Currently we have not added the heart rate, breathing rate. These are also like if we add more and more type of features to any model, it going to increase the accuracy and precision also. Like Google makes Google, any kind of company makes updation in their model because they want to achieve the accuracy and their prediction. So going to references, I have mentioned these are the references. These are the documents and links which is used in the diagrams.
Thank you,
So
Mr.
that's all. Thank you, sir.
Thank you. So any question from the participants?
Sir, I have one small question.
Yeah, okay.
Yes, sir.
We know that if a driver looks down or just
Yes, sir.
close his eyes for some period, do you have some duration for that? I mean, giving signal?
Yes, sir. Yes, sir. Yes, sir. We have the, like, driver is doing for like 2 to 3 seconds. Then the model will let it neglect, but it will measure that yes, such kind of activity is noticed. But we have set the petameter, like if the noding will be like 2 to 3 seconds, it the model will simply neglect it. But if it going to exceed the limited time we have already mentioned in the model, so it will going to market in the data set that yes, the factors are exceeding, so you have to alert the system.
Okay, thank you.
Okay, just one more
Mm.
question for me. Since you said you use SVM, support vector
Yes,
machine,
sir.
for as a classification, right? So how many
Yes, sir.
classes?
So for SVM,
How many classes that you use for this problem, or for this eye detection or something?
so
Yeah.
sir, actually, can you just repeat the question? I just mess up with it.
The classification. How do you what classes that you chose for this, for the SVM? What
Okay,
class?
sir. Classes like in SVM we check that so firstly we were checking like how other algorithms are working over it. They are just telling the uh, uh, factors like yes, the driver is sleeping or driver is awake or not. But we choose SVM because SVMs are many. In SVM we can put many factors like the sleep is not properly sleeping. He is a little bit sleep. There are 8 to 10 factors we have mentioned in the code, like little sleep, more sleep, and eye is nearly closed. Eye is going to be closed. So these kind of factors are mostly SVM algorithm is supporting us. That's why we choose the SVM for our model.
Okay, so thank you very much. Okay,
Thank you,
Mr.
sir.
Dipanshu.
Yeah,
Okay,
sir.
so we go to the next paper. Next presenter.
Yes, sir. So next presenter is the topic is machine learning based intrusion detection system by Ramatan Dr. Udaya Kumar, Mr. Udaya Kumar. Do we have presenter?
You have any presenter for the paper, or you have any presentation?
Machine learning based intrusion detection system is topic. So no one?
No one. I think we go to the next paper.
Yes, sir. Designing a predictive maintenance based algorithm for DC motor fault detection and classification. by Mr. Habib Satria.
Thank you for the opportunity.
What's the paper number before you start?
Good afternoon, sir and madam. First and association and the international conference of the technical advance in competition science. Let me thank you for the opportunity that has been given to us to be present an article about design a predictive maintenance based algorithm for detection and classification of the motor fault. Now let's move the main present about starting from the abstract. An algorithm based on prediction maintenance is present in this research study for the identification and classification of the motor fault integrities. The driven method such as machine learning algorithm, for extraction, data preparation, and sensor input by optimization maintenance products. The suggest algorithm seek to increase operational efficiency and improve the accuracy in so detection. Then interaction, the motor efficiency transform electrical energy into a mechanical machine. They are widely employed in variety of sectors, including robotic, aircraft, automotive, and manufacturing. Because this motor, the essential for the power machine car and other equipment is critical that the operation reliability on order minimize the on present production. Into the contents of the motor, predictive maintenance become particular critical do their widest use the critical role into industrial processing. For detection and classification and a key component in any predictive maintenance system. For the motor, a number of detection and classification strategies have been for utilizing the first method include machine learning, pattern recognition, and signal processing. The objective of this technique is to examine the operation data of the motor, which often by sensor that track variable like voltage, current, temperature, and vibration. The objective of this technique is to examine the operation data of the motor, which of the often accurate by sensor that track variable like voltage, current, temperature, and vibration. Although for detection and classification technique for the DC motor have advanced, there are still a number of obstacles to overcome and room for advance. For the motor, a number of detection of and clarification strategy have been proposed utilizing of average of methodology include machine learning, pattern recognition, and signal processing. Literature survey adopt analysis of the detection method for the motor in electrical car given Zhang and Li. Every address data-driven signal-based and model-based technique, stressing and benefit and drawback of each. Result and discussion for this study work, the processing and data agreeing procedure is essential to grading and the accuracy, the dependability of the data grade. In addition to explaining the location of the sensor and the frequency of data collection, this part gives a description of data, the acquisition system, and ways draw the stack in full in data preparation, such as reduction, outlier identification, and normalization, data collection system, and accurate and dependent data collection system in use to gather information about motor operation. This system is made up of a number of sensors. They are graphically posited on the motor to record crucial information and performance metrics. Among other things, the sensor may include temperature, vibration, current, or speed sensor. Lastly, while the proposed algorithm exhibits high accuracy in fault detection and classification in interoperability of its the decision-making process may be limited. Understanding of underlying reason for fault classification may prove challenge due to the complexity of the employed machine learning model. Feature assessment. This research article include with dot analysis of the development and algorithm for the motor the identification and classification based on predictive maintenance. The research find give important insight into the creation, efficiency, problem detection, and classification method, which will have a substantial impact on the file of prediction maintenance in DC motor. The suggest approach outperformance current technique in terms of accuracy, precision, result, and F1 score exhibiting and according result the precise detection and classification motor defection. The finding of the study have to detect when first of all the suggest algorithm over the deployment and automate method for location and categories motor defect along for from repair production to effect include the downtime and self-maintenance expenses. The study finds discussed in this paper help to improve prediction maintenance strategy for DC motor and prove new avenue for future research in this area. Will we eventually help authority and sector that dependent on the DC motor operation? Reference. Thank you, sir.
Okay, thank you very much for the presentation. Okay, Mr. Habib. Okay, so any question from everyone? From any participant? Do you have any question for this paper? So if no, just one question. What technique do you use for the fault identification?
Yes, sir.
Yes, Mr. Habib.
Yes, sir.
What? Yeah. What technique you use to detect the fault? Oh,
The technique algorithm, this predictive maintenance-based algorithm consent and several interactions takes design, effectivity, detect, and classify fault in the motor. The algorithm activates real-time sensor data from the motor analysis. It helps status and identification any deficiency from normal operation condition. This key step of the algorithm include data collection, feature extraction, feature selection, and fault classification.
okay. Okay, thank you very much for the presentation. So we go
Thank
for
you,
the
sir.
Thank you, sir.
Sir, can we move to the next?
yes.
Next paper by the paper number ID 404 by Mr. Aryan Agarwal, paintings with photos classification using deep learning.
Am I audible?
Yes, sir. You may share your screen, sir.
Sure. Is my screen visible?
Yes.
Okay. A very good afternoon to one and all present here. I am Aryan Agarwal from the Graphic Era Hill University, Dehradun, and I am here to present my research on paintings versus photographs classification using deep learning, which is paper ID 404. So, sorry.
Let's continue.
So the table of contents of this presentation includes abstraction, introduction, literature survey, proposed architecture, results, future enhancements, and references. Moving to the abstract, uh, identifying a picture's content based on wait a second, sorry. Sorry. Identifying a picture's content based on its attribute is a fundamental task in computer vision known as image classification. In this article, we provide a study on the use of machine learning algorithms to categorize images of paintings and photographs. We investigate the performance of different models such as decision trees, convolutional neural networks, and support vector machines. We also look into how data preprocessing methods and hyperparameters tuning affect how well the model performs. According to the results of our experiments, CNNs classifying artworks and photographs with an accuracy of 98%, which is the highest among all. Moving to the introduction of our research, image classification in computer vision is very crucial for applications in like security systems, driverless vehicles, medical imaging, etc. Deep learning, especially convolutional neural networks, has significantly improved the accuracy and effectiveness of picture classification. This study focuses on classifying artworks and photographs, which has real world application in digital archiving, authentication, and preservation. These tasks are challenging due to the distinct characteristics of paintings and photographs. Moving to the literature survey, image classification has been a prominent research area in computer vision for many years, with numerous studies conducted in this field. Like, for example, CNN in image classification was one of the paper was Krivesky demonstrating the effectiveness of convolutional neural networks in achieving state-of-the-art performance on the ImageNet dataset, marking a significant milestone in image classification. Transfer learning in image classification has emerged as a powerful method for image classification. It is like a pre-trained CNN models like VGG, ResNet, or Inception. These are fine-tuned on smaller datasets, significantly enhancing their performance. Some more studies on classification of paintings are Louis et al. Used a CNN-based approach to classify Chinese landscape paintings into different styles, achieving high accuracy. They et al. Employed a hybrid approach combining CNN and SVMs to classify Indian paintings, demonstrating the effectiveness of combining multiple models. Others, classification of artworks and photographs. Some other papers are Louis et al. Utilize a CNN-based method to categorize pictures of paintings and photos, showcasing the efficiency of CNNs in this task. Young et al. Employed a hybrid strategy combining CNNs and SVMs to classify paintings and photographs, underlying the effectiveness of merging multiple models. Diverse approaches in image categorizations are the use of CNNs and transfer learning are just a few examples of the diverse approaches. Studies have also highlighted the effectiveness of combining multiple models in the classification of artworks and photographs, providing a valuable insight into methods and procedures for utilizing machine learning in this context, in differentiating the paintings and photographs. Next, we move to the architecture. So architecture basically involves first data selection. Data was selected from various sources like internet repositories and art archives, including images of various resolution sizes and artistic styles. Next, we come to data preparation. In this, data was divided into training, validation, in test sets to maintain class balance. Also employing sliding window method to partition images into 512 by 512 non-overlapping tiles for grained feature extraction and efficient training of the binary classifier, which is seen. Next, we come to the transfer learning process in VG16 model. As we know, VGG16 model is a leveraging pre-trained known for its high performance in large-scale picture classification tasks. Whereas transfer learning includes utilizing learned features from VG16 model to expedite training and enhance overall accuracy of binary classifier. VG16 includes 16 layers in total, including convolutional, max pooling, and fully connected layers, pre-trained on ImageNet dataset, then fine-tuned by freezing initial layers and adjusting later layers for specific binary classification tasks. Next, we come to the training procedure. Training procedure basically involves feeding pre-processed dataset into VG16 model while batch-wise training, employing backproportion to update models weight with small batches of samples. Next, we come to the fine-tuning. In fine-tuning, we unfreeze the final layers while keeping initial layers frozen to adapt model for binary classification and retaining generic features from pre-training while learning specific task-specific features. Next, we come to validation set evaluation. It was basically to perform access models performance on a separate validation set, which can give as a result matrix which includes accuracy, precision, recall, and FN score. Next, we evaluated the dataset. Testing model on an unseen set to confirm its capability, to check its capability, how accurate it is, how fine the model is working. So, what results we get? Basically, 400 samples were evenly split into paintings and images, which were used to assess the binary classifier. So this was the test dataset. This is the classification report matrix, how what were the precision, recall, and F1 score came of the painting class and the photograph class. So the results demonstrate the effectiveness of the binary classifier in accurately classifying paintings and images. High precision and recall scores indicate robust performance across both classes. The balanced F1 scores further confirm the classifier's reliability in handling diverse datasets. Next is future enhancement. So there is still room for future enhancement despite the outstanding results achieved by the current binary classifier. Potential research directions are exploration of additional data augmentation methods like color alteration or image blending to further improve. Further research into trained models and fine-tune are exploring additional trained models and fine-tuning techniques, which may lead to even higher accuracy in classification. Next, we come to the references that we use to do the research and create this PPT. That's it from my side. Thank you.
Okay, thank you very much for the presentation.
Thanks.
Okay, any question from participant? Anybody have any questions? If not, then I have question. You use the AI techniques for the photos, right? For the photos and the paintings, to do what?
Sorry?
What you want? You use the photos and paintings, right?
Yeah.
To
To
what?
categorize them, to if the model can categorize if these are the photos and these are the paintings or not.
So how many paintings that in the data?
In the data are approximately 2200 photos.
For both photos and paintings.
2200 photos and 2200 paintings.
Mhm.
Approximate.
Okay. But okay. So okay, thank you very much, Mr. Aryan, for the presentation.
Thank you, sir.
Thank you, Mr. Arya.
So we go for,
Professor, may we move to the next, Dr.
yes, sure.
So our next presenter is paper ID 461, Enhanced Spam Detection Models through Retraining and RNN Models by Hariharan Shanmuga Sundaram. I'm sorry for spelling,
Yes, sir.
my spelling.
Thank you. Sir, give me a couple of minutes to present the PPT, sir. I could kindly request you to give me a couple of minutes.
Sir, if your PPT is not ready, so okay, it's ready. Okay.
Yeah, sir. Good evening, everyone. Esteemed IEEE delegates, ladies and gentlemen, and distinguished Noor Isri Abdul Wahab sir and Alishar Jalilov sir. It's a immense pleasure to meet you and to present our paper and what the work we have done for the past couple of months in our college. And yeah, so our paper title is Enhanced Spam Detection Model through Retraining and RNN Models. So yeah, could you go to next slide, Mr. Manikantam? So yeah, this is the abstract. So generally, our abstract include it includes the very predominant approach to handle the spam notifications in our mobiles and in our electronic gadgets as well. So this generally includes model performance, user experience in data science aspect, and machine learning as well. So majorly it would focus on retraining. That defines that it's actually allows to adapt to the different users. So retraining is generally the term retraining is coined from training. That the major difference is that training will be happened from the scratch and right from the start beginning, but the retraining is resuming the process after training the model. That's how we coined the term called retraining to our paper. So to be more precise, and so yeah, this includes updating models with user interactions and striking performance improvement, and majorly we focused on computational efficiency. As in this fast and furious world, we are very very precise at our computational efficiencies, and to make our things very quick and easier as well. So yeah, we used methods like RNN, bidirectional LSTM, and stacked LSTM. So majorly the keywords here are, to walk you through generally, the keywords here are user interaction, retraining, new data, spam and ham. The whether for an instance, Wahab sir, think that you are using, for an instance, you got a mail and you wanted to know that is it a spam or is it a ham. For that, that is it a useful one or it is not. So it can be determined by our model. We put our efforts to build so forth, and that sort of model which will be discussed furtherly. So Mr. Manikantam, could you slide? So yeah, the introduction generally, as a team, we went very close to the community and saw a couple of problem statements. So we generally stuck with this problem statement because as a data science aspirant, we are looking forward to make everything easier to the people and go everything hand in hand. So the problem statement is here, to be precise, it would handle the notifications within our technical gadgets, and it will determine whether it is a whether it is a spam or ham, as I discussed earlier. So it includes the process of understanding the fundamental patterns of the process to perform the interactions accordingly, and applications for incremental retraining includes recommendation system as well. Yeah, we will discuss accordingly. So that differences. Yeah, Manikantam, could you go to the next slide, please? So yeah, when we, as I mentioned earlier, sir, as I mentioned earlier, that when we went close to the community and watch a couple of problems, so yeah, to be precise, we picked the spam and ham problem statement, and we went deep dive into the existing system. So we found majorly these two, I mean, mobile app notifications. Yeah, as a gadget users, we daily, deal with a very lot of junk and spam mails, which can create very chaos in our technical gadget, and which would lead to steal our information as well. So yeah, the first one is that mobile app notification settings as well, which includes the manual settings to the user, and the second one is relevance feedback system. This includes employee reference feedback mechanism, which allows to provide feedback on the notifications they are fed, so can be continuously improved to the relevance and accuracy of notifications. And yeah, so forth. I would like to extend this presentation to the Mr. Manikantam to continue as a next furtherly.
Yeah, thank you, John. So I will continue from this. So as soon as possible, yeah, next slide is literature survey. So we can see there are problems with the notifications, like attackers frequently employ the domain spoofing, like they will attack with many mails or messages to the user. So at the bad situation, once a user clicks the link, he will be like hacked, or the information will be goes to the hacker. So according to this, we will be detecting the mails, it is a spam or ham, and by the RNN models and LSTM models, we can do that. So lastly, very limited or no usage of retraining aspects in this phase. So coming to the proposed architecture, let me continue with the simplest way. So we have two sections here. One is pre-model phase and second one is retraining phase. Here, the pre-model phase is a general thing we can see in everyday life. So data will be pre-processed and vectorized to pass into the model. And we can see in model, we can compile it and fit it, so that the graph will be generated in the fit model. So according to the graph, we will be predicting the result. So whenever the new data occurs, then also we will append to the data, that is the old data, and we will do the same thing generally. But here the retraining does is, it will pre-process the data and vectorize it and go to the fit data, not to compile, because we are resuming where it starts, so ends. Okay, so the graph will be plotted where it ends. So according to that, it will predict the new prediction with the new data. So that's how we optimally predict the model, and that's it. We will get less time to predict, even though if we have a new data to the model. So as we discussed, we have an initial stage and training phase and retraining phase. So this approach aims to save the time and memory resources while enhancing model performance by efficiently updating model priorities in response to new information. So here are the results. Will be continued by Santosh. Yeah, Santosh.
Thank you, Manikantam. So the results of our research is we have used three models, like one is LSTM and the other is bidirectional LSTM and the stack LSTM. And we have used for training a data set. We have used these three models, and we got the more accuracy in the bidirectional LSTM. So this is occurred by the help of the retraining. So and here we can see that why we use the retraining. So by convention, in the conventional method, we want to train the data from the scratch, but by the help of the retraining, we can reduce the time of training the model when a new data is arrived. So we can see the time taken by the conventional method is 50.7 seconds and the retraining is 12.3, which is very lesser. So we use the retraining of the model, by which decreases our time for retraining the new data. So now coming to the future enhancements. So we want to integrate these models with the Android development and the Flutter framework, which can help us to detect the context of the notifications from the notification bar, and we can help to predict the spam and ham and by the user interactions, and we can remove the notification quickly when the spam notification arrived in the notification bar. So we will be using these models with the Android ecosystem and the Flutter framework for the advanced notification manager and the user experience. These are our references, some of the references where we got the data and the models that we want to use. Thank you.
So yes, sir, we are open to questions and we would like to answer to your questions according to our knowledge as well, sir.
Okay, thank you very much for the presentation. So anybody have any question from the participants? Okay, for me, question from me. As far as I know, the LSTM and LSTM is real time technique, right? So for the data that you have you use for is it the offline? You train first, and then the retraining is when it's connected in real time?
Yes, sir. That's actually a great question. As we mentioned earlier, we took a couple of models to train our model as well, but majorly we have focused on LSTM because LSTM is a great recurrent neural network, as we mentioned in our title as well, because that includes encoder and decoder, which helps to make more efficiency and to fetch the more result more accurately. So henceforth, and as the question you raised, that we initially took our real-time data and made it to and given it to the model which have built offline, as you asked, and then we tried with the what are the existing systems, and moreover we tried with the conventional methods which we earlierly shown you in the results section and part. So yeah, yes sir, we tried it offline and we tried it online as well, sir.
Okay. Okay, thank you very much for the question, for the answer. And thank you very much for the presentation. Dr. Alicia, any question or we continue?
No, sir.
Okay.
So next presentation, paper ID is 339.
Thank you,
Sir.
sir.
Thank you. Thank you.
Thank you. Next presentation is paper ID 339, analysis of focused web crawlers, a comparative study by Vayan Suryasa. Do we have
the presenter?
Anybody?
Yeah.
Paper ID 339. Okay. Professor, may I move to the next one?
Yeah, please.
They will join late. So next is paper ID 190. So 190 is
yes, we are present.
Yes, sentiment
Yes, sir.
analysis of Twitter data using machine learning.
Yes.
It's by Pooja Dahiya, Miss Pooja.
Shall I present?
Yes,
Yeah.
of course. Please share your screen. Miss Pooja, you are muted. Unmute your mic.
Yes, sir. I will be starting with the presentation.
Oh, okay.
Okay. So, good evening, everyone. Today, I, Archie, along with Pooja and Rashi from Indira Gandhi Delhi Technical University from Women, will going to give the presentation of our research paper, which is sentiment analysis of Twitter data using machine learning. So, first comes the abstract. First comes the abstract. So here we have used the social media platform Twitter So Twitter sentiment analysis is basically to extract and access sentiments from tweets using different ML algorithms and categorizing them as positive, negative, and neutral. To ensure high accuracy, data preprocessing is used to remove noise, misspellings, and emojis in the dataset. The importance and potential of Twitter sentiment analysis for analyzing popular opinion on a range of subjects are highlighted by this study. So then comes the introduction. Twitter, as we all know, is a well-known social media platform that provides us with variety of viewpoints and real-time information in our daily lives. This platform stands out since it has a unique way of sharing brief messages to a large audience in the form of tweets. Sentiment analysis is a method of identifying and classifying emotions in text, and Twitter data is a useful source for this kind of study. The research paper discusses ML algorithms for Twitter sentiment analysis and also addresses with benefits and limitations. In addition to attempting to advance the field of sentiment analysis for mental health, our paper highlights the significance of using social media data responsible for mental health studies.
Existing systems. In the realm of sentiment analysis, professionals rely on several key tools, few of which are TextBlock, NLTK, Vedar, Tweepy, and IBM Watson. TextBlock is a Python library which offers API for common NLP tasks. It is a sentiment analysis based on lexicon of words. Words have associated sentiment scores, which indicates the polarity, that is positive, negative, or a neutral word. NLTK is a natural language toolkit Python library which has various modules for text analysis and has a wide array of tools such as tokenization, stemming, part of speech, tagging, etc. Vedar, valence-aware dictionary and sentiment reasoner, is a lexicon and rule-based sentiment analysis. It is highly effective for social media because it excels at short text analysis, including emojis and slang. Tweepy, a Python library, enables a user to access Twitter's API, which is crucial for real-time analysis and monitoring public opinion on Twitter. So it is mostly used with TextBlock or Vedar. IBM Watson is an advanced machine learning algorithm, unlike the above mentioned, which are Python libraries. It also recognizes specific emotions and entities within a text. Literature survey. All the numerous studies helped us in defining a methodology for our research paper. Majority of them use random forest, SVM, naive Bayes, and few of them explored deep learning algorithms like CNN, convolutional neural network. Our proposed architecture compromises first of data collection, second data preprocessing, which involves handling of data removal, text cleaning, and tokenization, followed by training and testing on key algorithms that are support vector machine, naive Bayes, random forest, and logistic regression. This approach ensures precision and efficiency in our analysis. Data collection. Our dataset consisted of 3 columns. First was of tweet labels, that was 0 or 1, 0 for negative comment and 1 for a positive comment. Unique tweet ID, and third, the raw tweet text itself. The dataset consisted of 31,500 tweets and was stored in a CSV file. Data preprocessing. It includes 8 steps. First, importing the dataset using the Python Panda library. Second, handle removal. To concentrate solely on the content of the tweets, we remove Twitter handles, storing the clean tweets in clean tweet column. Third is cleaning text. After handle removal, we remove special characters, numbers, and punctuation marks from our tweets, and while retaining only the alphabetical characters and hashtags. Fourth is short word removal. We filtered out any words with fewer than 3 characters. That is words like is, and. By eliminating such words, we removed any irrelevant noises from our analysis. Fifth, tokenization. Tokenization is a function from NLTK, which dissects the tweets into words that are called tokens, after which we use the process called stemming. It reduces the words to its root form. Example, if we have a word like swimming, it will be reduced to swim by removing the suffix and prefix from the word. After that, to maintain the context, we tokenize the words were reassembled and to a coherent and readable sentence for further training and testing. And eighth step is hashtag extraction. By recognizing the significance of hashtags in social media, we extracted them for non-sexist and sexist tweets, which shed light upon popular topics and trends within the dataset.
Visualization. We have learned valuable insights from visualization techniques like word cloud and bar chart. Word cloud. We have created visually captivating word clouds that represent the most frequently used words in our dataset. Positive sentiment word cloud represent themes in the positive tweets, and negative sentiment word cloud represent themes in negative tweets. Bar chart. We have created visually appealing bar charts in which top 10 hashtags by frequency are selected and visualized for both positive and negative sentiment. Next comes the results and the discussion. Here is the graphical representation of our results. Next is the numerical representation of our results. We have trained and tested with 4 different machine learning algorithms, that is, logistic regression, k-nearest neighbors, SVM, and naive Bayes. And the above results show that the highest accuracy is obtained by SVM, which is about 94.73%. Next comes the future advancements. These are a few future advancements that carry significant potential for pushing the boundaries of Twitter sentiment analysis. First, emotion recognition. Going beyond simple positive, negative, and neutral sentiment classification and delving into the recognition of specific emotions expressed in the tweet, such as joy, anger, sadness, or surprise. Second, real-time analysis. In this research paper, we've taken predefined dataset, but we can develop a system capable of real-time system analysis to provide instant insights into the trending topic and events as they unfold on Twitter. Third, cross-platform analysis. Extend the sentiment analysis to other social media platforms to provide a more comprehensive view of public sentiment. Fourth, user feedback integration. Consider integrating feedback mechanism to allow users to contribute to the training and the improvement of the sentiment analysis system. Next comes the reference. These are the references that have helped us in making this project successful. Thank you for listening to our presentation.
Thank you very much for the group, for the team. Okay,
Thank you, sir.
question from the floor or from the participants? So if no, okay, my question, I see just now from the presentation, the sentiment is just sexist and non-sexist. So how many type of sentiment that you consider for your work?
So we have considered 2 classes in our dataset, that is the positive and the negative. The positive dataset, the positive class is considered to be non-sexist, and the negative sentiment class is considered to be sexist.
So only two classes, right?
Yes, sir. Binary classification.
Okay. Okay. Thank you very much for the presentation. And then...
Thank you so much, sir.
Thank you, sir.
Thank you.
So, Dr. Alicia, maybe we can go for another paper, next paper.
Yes, sir. Yes, sure. Paper ID 466-470. He asked you to present a little late. Maybe if he is with us.
No, sir, I'm available now, right now.
Okay, okay. So now then let me give chance to paper ID 466, Unlocking Insights, Diseases Recognition in the Human Eye Using CNN and the Random Forest by Ms. Ankita Suryavanshi.
Before the presenter start, I just want to ask Dr. Alicia that I will leave the room in 15 minutes because
okay,
I
sir.
some other engagement. So
Understood, sir. Actually, we should have two session chairs, but unfortunately, Dr. Ranjit Singh couldn't join us.
Okay.
May I start, sir?
Yeah, please start.
A very good afternoon to all of jury members. My name is Ankita Srevanshi and I am here to present my paper on unlocking insights, disease recognition in the human eye using CNN and random forest. Towards the contents I have used. These are abstract, introduction, literature, survey, proposed architecture, results and decision, conclusion, and references. Moving towards the abstract portion, an integral sign of both physical and mental health, pain is a complicated and multidimensional component of the human experience since it influences diagnosis, therapies, and overall patient care. Timely and accurate pain evaluated is critical to the medical field. Innovative methods of measuring pain are necessary, though, because pain is suspective and some population find it difficult to communicate verbally. As we can see, to address this need, the project aims to transform pain detection by using facial expression analysis, a thorough framework that utilizing cutting edge technologies such as deep learning and forest categorization, neural network based on convolution and pain tasking. Picture processing is presented by the researcher. The model accuracy and the generalization skills across a wide range of pain intensity levels are demonstrated by the precision recall and FN values measures beyond its direct clinical uses. Moving towards the introduction portion, as we can see, the sophisticated and amazing sensory apparatus known as the human eye is crucial in determining. Researchers see the outside world. Ocular illnesses are a common phenomenon that affects the entire world. If know several eye disorders such as cataracts, glaucoma, and diabetic retinopathy have the potential to result in blindness or visual impairment. In this paper, we have identified various number of eye disease by using convolutional neural networks and random forest. As we can see, these approaches make use of data-driven insights to enable doctors to make wise decisions, hence raising the standard of patient care. The sophisticated and amazing sensory apparatus known as human eye is crucial in determining how authors see the outside world. The ability of the human brain to record, analyze, and interpret visual information is a crucial component of the human condition. Moving towards the literature survey, scientists introduced identification and treatment for cataracts are crucial for halting the progression of visual loss to blindness. A practical and effective supplementary diagnostic strategy is suggested due to the shortage of healthcare facilities in rural areas and high cost of optometric logistics. Slit lamp diagnosis. As we all know that looking towards some previous studies, I have gathered the data. The fundus pictures are subsequently processed using grayscale, resize, and dynamic transformation procedures. The automatic detection of cataracts in fundus pictures is addressed in the research using a unique deep neural network. As we can see, to save patients without losing their visions, uh, the duration of treatment is essential. Numerous research quickly showed how retinal fundus images may be found utilizing a variety of image processing method. In this study, they used a hidden Markov model to use random forest, and they were able to reach accuracy. Is moving towards the methodology section. The researcher development a thorough methodology that includes data gathering and preparation, data enrichment of or enhancement, model refinement, and collaborative learning and performance assessment and interpretation through the painstaking execution of several steps. We have used the method of acquiring and preparation data serves as a crucial cornerstone for the research described in this paper. Medical images of different eye conditions, including cataracts, glaucoma, diabetic retinopathy, age-related macular degeneration, were painstakingly gathered to create a comprehensive dataset from reputable medical databases, research facilities, and healthcare facilities to train efficient machine learning model for the identification of human eye diseases. Information enrichment and enhancement are essential technology for improving the data set quality and diversity. These tactics use a various of ways to enlarge and improve the data set ability to capture intricate patterns and enable precise disease classification by creating several copies of the same image augmentation method for light relation fitting and group. This is the image which is showing different phases of methodology. As we can see, we have used three convolutional layers, a max pooling layer, flattening, and random forest with, to classify the diseases, the different diseases, and we got six number of the different classes of different diseases. Moving towards the results and discussions. The conclusion metrics for the illness detection model performance on a wide range of human eye. As you can see in figure 2, a conclusion matrix is used to for the different classes to identify the rare disease class is represented by each row in the matrix, while the anticipated disease class is represented by each column. The count of occasions where the actual diseases and anticipated disease match is shown by the number within the matrix cell. When the actual and expected disease match, the confusion matrix is diagonal. Entire entries show accurate predictions. For instance, a 289 instances of cataracts were properly identified as such, proving the model ability to identify the ailment. Some of diagonal cells do, however, show misclassification. Examples include the misclassification of diabetic retinopathy cases such as cataracts, glaucoma, and blepharitis. These are all the results in which we can see the dimensions of the layers. As we one second, um, as we can see that it provides a thorough analysis of the performance of the illness recognition model for several groups of eye disease. The table displays the journal reliability and averages as well as the precision we call F1 score, as well as support for every illness category. Precision illustrate the model category to reduce false positive by measuring the ratio of accurately predicted positive results. Moving towards the conclusion section, moving towards the conclusion section, in conclusion, our research demonstrate an efficient and reliable approaches for the diagnosis of human eye problems using cutting-edge machine learning techniques, cataracts, glaucoma, and so on, are just a few of the many eye diseases that we have skillfully incorporated into a complete framework that allows for correct diagnosis. CNN exceptional capacity to extract disease-specific features from medical pictures is supported by its carefully created multi-layered architecture, which was designed with thoughtful consideration of filter sizing. These are some references which we have used in the paper. Thank you.
Ms. Ankita, did you stop sharing your presentation?
You completed your presentation?
Yes, sir, I have completed my presentation.
Thank you for the presentation. So, we have any question from the participants? So, if no, a question from me. So, how many medical images that you use for the project or for your work?
So you're not audible properly.
Not audible. How many images, the medical images? How many medical images you
Okay,
use?
sir. I have used 2002 images.
2002.
Yes.
But all yeah, the medical images is X-ray, X-ray image, or how is the image is it in color, or what is the condition of the image?
Uh, I have collected the data set from Kaggle, and those are all colored images.
Color images. Okay, okay, okay.
Yes.
Okay. Thank you very much for the presentation.
Thank you so much, sir.
Okay, so okay, I leave this room and give back to Dr. Alicia for the.
Yes, sir. Thank you, sir. Actually, sir, my research area is math. That's why I'm not asking too much question. Actually, I'm a mathematician, not an person. Yes. So that's why I'm not asking too many questions, because this is a little far from me.
Yeah. Okay, so I think we have covered most of the papers. I don't know.
Actually, the two more papers left. One paper by Miss Ankita, one more, and one paper by Vignesh Loganathan, paper ID 295. If this
May I
participant is...
continue with my another paper too?
Yes, yes, it's okay. But let me ask first, Professor Noor Abdul Wahab.
Yes, sir. I'm ready. I'm ready to present.
Yes, yes. First, I think first let us listen Miss Ankita, because she has two consecutive papers. Then we'll let you present. So
Okay, okay, sir. No issues. No issues. We'll be waiting.
Thank you so much, sir. I will present my paper. I'm sharing my screen right now.
Yeah, Dr. Alicia, I'm leaving the room. Okay.
Thank you very much, sir. Thank you very much.
Thank you all.
Thank you. It was a big pleasure.
Sir, my paper ID is 468 right now, na?
No, 470.
Okay, fine. I have four papers. I think that is in different room maybe.
I think so. Yes. As
Yeah.
for this session, you
So
are
my
given.
screen is visible to you or not?
Yes, it's visible.
Okay, thank you so much. I'm starting my presentation.
Yes.
A very good afternoon to all of you. My name is Ankita Suravanshi and I'm here to present my paper named as Automated Detection of Pain Across Varied Intensity Levels Through the Fusion of CNN and Random Forest. Moving towards the contents, we have used abstract introduction, literature survey, produced architecture, methodology, results and discussion, conclusion and references of the presentation. Moving towards abstract section, in the medical field, accurate pain assessment is still difficult, except especially when verbal communication is restricted. In response, by utilizing state-of-the-art technology, this research offers a strong and automated approach to pain identification. Feature restriction is done using convolutional neural network. Face expression analysis is done using deep learning techniques, and classification is done using random forest. Accuracy and the generalization abilities of the model are demonstrated by performance matrices such as precision recall and Evans score, promising development in patient care, early intervention, and comprehension of pain manifestations. Moving towards the introduction section, an essential human experience, pain serves as a crucial signal to warn people of impending injury or harm. The precise and timely measurement of pain, however, is not always simple, especially when it comes to people who might have trouble verbally expressing their discomfort. Such such as young children, patients, the alternative techniques of pain evaluation are necessary in these situations. This study main goal is to close the existing gap in pain measurement techniques, especially when still to give medical practitioners a new tool to improve patient care and increase the precision of pain assessment in a range of clinical situations by automating the procedure of pain detection. In this study, the model can adapt to acquire knowledge regarding the complex and variable nature of pain-related facial fluids because of the multi-layer approach. Reverse literature survey. This study compared the outcome of two individuals with the dose of the random forest classifiers. Basic model are three listed assumptions. First model puts forth the random forest to categorize action unit series of descriptioners. The second uses a modified version of MobileNet V2CNN to categorize pictures of faces that combine three distinct points within the image. Towards the methodology section. The study compared the outcomes of two investigators fires developed an basic model archive that supported data acquisition and data cleaning and processing and analysis of modeling and interpretation. The second uses a modified version of very precise and dependable category when pictures of faces that diagnose and classify different level of points within the indicated by facial expression was developed as a result of this methodological approach. Dataset preparation and collection from the cornerstone of each machine learning driven research project almost. This is the methodological stage in which we are using two convolutional layers, next pooling layer, then again two convolutional layer, again pooling layer, then cycling layer, and a random forest to classify five classes of the output. The phase of data processing and modeling emerges as the central focus of research and favors seeking strong pain detection across varied levels of intensity through facial expression analysis. This analysis steps involve a methodological investigation of the corrections between facial expressions and pain surety. The research journey culminates at the pivotal point of interpretations and validations, wherein the knowledge obtained from data analysis as well as modeling is tested to guarantee the efficiency and dependability of the pain detection system. Moving towards the results section, as we can see, uh, the link between reality pain level we can categorize it and the model prediction is shown in the matrix. This is the confusion matrix which we have used. The model advantages and disadvantages by looking at each cell in the matrices, which represents the number of examples that fit into the given category instances when the model accurately determines the pain intensity as displayed as two positive, the diagonal members of the matrices. For example, authors find 492 positive values in the cell that corresponds that A category and so on. As we can see this table, there are different classes and in these all the classes we are we are able to provide a thorough examination of the effectiveness of the facial expression analysis based pain intensity level detecting method for every single one of the pain severity level categories that the framework seeks to categorize its methodological deliveries. Important performance data. With the use of these matrices, which include accuracy, recall, F1 score, assistance, and correctness, authors can fully comprehend the capabilities of the model. Towards the conclusion section, the research has produced a thorough and practical solution in the quest to automate pain identification through facial expression analysis. Researchers have created a reliable system that can discriminate between different pain thresholds by combining deep learning methods, random forest classification, and convolutional neural network and molecules noise preparation. That is, the results show how well that system can mimic people expression when they are in pain with high recall precision and F1 score values across a range of pain levels. This performance demonstrates the diff system moving towards. These are all the references.
Thank you, Ms. Ankita. Do we have any questions to our presenter? I think Dr. Vignesh, you are the senior one. So if you have any question, please. Any questions? If no more questions, thank you very much, Ms. Ankita, as you presented such two beautiful presentations, wonderful presentation. Thank you. Good luck.
Thank you so much. Thank you so much, sir.
So we move to our next presentation, paper ID 295 by Dr. Vignesh. Topic is vehicle density and emergency vehicles detection for smart traffic control. Please, sir. Dr. Vignesh, I think you are muted. Please unmute your mic.
Hello, am I
Yes.
audible? Yes.
Now, yes.
Okay, okay. So
Sir,
I'm starting with my presentation. Yeah.
please, sir.
Myself, Dr. Vignesh, myself and Mr. S. Samraj, Assistant Professor, is going to present this paper. Topic: Vehicle Density and Emergency Vehicle Detection for Smart Traffic Control. So with this abstract of my paper, the aim of this research paper is to propose a novel approach for managing vehicle density in urban areas through the detection of emergency vehicles. The suggested system employs sophisticated computer vision methodology to analyze real-time traffic data and efficiently detect emergency vehicles, hence facilitating streamlined traffic management and prioritized passage. The empirical findings provide evidence for the efficacy of the staggered approach in mitigating traffic congestion and enhancing emergency response duration. So, to increase urbanized and growing number of vehicles in urban area to significant challenge in traffic management. Traffic congestions, particularly during peak hours, hampers the efficiency of the transportation system and increases travel time for commuters. Emergency vehicles often face difficulties in navigation through congestion, which can result in delayed response time during a critical situation. To overcome this and addressing these challenges requires innovation approach that leverage technologies such as computer vision and smart traffic control. So traditional traffic control mechanisms such as traffic signals and manual enforcement have limitations in efficiently responding to the traffic conditions that providing priority to the emergency vehicle. Need for an automated system that can accurately detect the identifying of emergency vehicles in the real-time system, enabling effective traffic control and prioritize the passage. So I have surveyed a few literature that Zhang et al. Proposes a smart traffic control system that utilizes vehicle-to-vehicle infrastructure communication to prioritize emergency vehicle. Through this simulation, the authors demonstrate the effectiveness of their communication in the reducing of emergency vehicle response time. Vinyl et al. Presents a real-time traffic density estimation approach for the smart management system by fusing data from multiplication of source such as video camera and loop detection. The author achieves accurate traffic density estimation, which is crucial for effective traffic management. Ma et al. Focus on an intelligent traffic light control system based on vehicle density estimation. The author developed an algorithm that estimates vehicle density system using data for connected vehicles. Experiment results showcase the system's ability and to reduce congestion and improve traffic flow. Glue et al. Proposes a novel approach for vehicle density estimation in smart cities. Their method combines machine learning algorithms and sensor technologies to accurately estimate vehicle density as confirmed by experimental evaluations. So to develop a vehicle density estimation technique that can accurately analyze real-time traffic data and provide an understanding of traffic flow and condition. Remaining, my co-author will present. Sam Raj.
Thank you. Am I audible now?
Yeah, you're audible. You can use.
Okay, thank you for the nice introduction, Dr. Vignesh. And I'll just continue with the proposed architecture. So, in the methodology of what we are proposing now, we are going to follow some vehicle density estimation and also the detection of emergency vehicle together so that we can manage the traffic smartly. So, that's what the main aim of this research proposal. Okay, as per the methodology, we use at the initial stage of this architecture. First step is about data collection and pre-processing. How we are going to collect the data. So there were several methods have been followed by just collecting some sensor data by installing some sensors along the roadways, detecting the density of the roads, and like that. In some cases, the audio analysis by recording some audios. If there are any emergency vehicles like ambulance moves on, through the sound analysis, vehicle windshield can be detected. And like that, the computer vision technologies like video recording and video analysis process yields the result about where the emergency vehicles are moving on. And through the video analysis also, we can find out the density of the particular road, the traffic congestion, and those details element. Okay, so that's what the first motto of this project. So for this purpose, we need some data collection and the pre-processing. In our system, we have planned and we have proposed to collect data through a visual analysis, visual recording, and then the second data. So vehicle density estimation. So vehicle density estimation is done through some machine learning algorithms like YOLO and faster or CNN. So these are mostly appropriate for a video analysis system, but with the computational effectiveness, it has to be considered. Okay, and finally, emergency vehicle detection with the same video analysis tools like deep learning models, including convolutional neural network analysis. We are able to detect emergency vehicle. Okay, by collecting all those details and aggregating them through regression analysis models, we can predictly analyze for all the traffic conditions. Like in the low traffic and mild traffic, we are already able to control the traffic. But in the time of traffic congestion, where heavy traffic is already there, and we are facing some tragic place, and the emergency vehicle is moving on. At the time, we have a great problem there. That's where this algorithms is found most helpful. That's what our proposed architecture. So with the experimental setups, we are able to perform. So with the given data sets, with the different streets and all, the performance metric have yielded a good results in terms of MEAE, RMSE, and FN score precision, recall. These are the few evolution metrics used in the machine learning algorithm. So that's how it goes on. It doesn't end here with the current result. We want to improve something more in the future enhancements by giving some other new algorithms to make it the computationally most effective. And as it imparts some edge detection algorithms, some edge AI accelerators which are installed at the traffic station itself, and smart traffic control algorithms, and also some traffic control systems which can adaptively change over the situation can be implemented. That's what our future scope of the project. Okay, so these are the few papers we have taken references from which we have got our idea and proposed our new methods. That's all. That's all for the session. Thank you, sir. Any questions? Queries?
Thank you, Dr. Vignesh and yes. Any questions from participant side? No questions. Thank you, Dr. Vignesh, for wonderful presentation.
Thank you, sir. Thank you. Thank you.
Yes, we have two more presentations left. Do we have paper ID 339? Wayan Suryasa. So the topic is analysis of focus web crawlers comparative study. No. So, and one more last is paper ID 170, machine learning based intrusion detection system. They were absent, just I wanted to recheck one more time. Thank you everyone for wonderful presentation. This is the end of our session, this session 4. So our sessions will be continued tomorrow by morning. Have a nice day. Good luck to your research field and best of luck. Hope to see you again. Everyone, it was wonderful 2 hours. Thank you.